In this video, we're going to talk about factoring polynomials. And so what is factoring? When we factor polynomials, we're finding an equivalent expression that is a product of factors. So for example, let's take this polynomial here, 2x squared plus x minus 6. When we factor it, we are wanting to express it as a product of factors, which is what we have here on the right-hand side. Now, when we factor, we want to factor what we call completely. And to do that, we're trying to get prime factors. And what that means is that each of those factors can't be expressed as polynomials of an even smaller degree. And so these two factors that we have here, they're both degree 1. And that means that in each set of parentheses, the highest power of x is 1. And so because of that, there's no common factor of the terms or a special property that we can use to factor either one of these further. Now, when we're given a polynomial and asked to factor it completely, it can be complicated, and it's not an exact science. And because of that, we have a lot of different strategies that we can try in order to factor a polynomial, but not all polynomials are actually going to be factorable. Now, in this course, when you're asked to factor a polynomial, you will be able to use one of these strategies, but as you go beyond the course, every polynomial you encounter is not always factorable. So let's go ahead and look at some strategies that can help make this process more manageable. So here I have a flow chart that kind of runs through the steps to help us guide us in our thinking as we're looking what to do with a polynomial and how to factor it. So first thing we're going to look at is, do we have a common factor? If we do, then we're going to want to factor out the greatest common factor. If you've forgotten what a greatest common factor is, let's review that really quickly. So if I had the number 6 and the number 3, and I asked you to find the greatest common factor, we would first need to know their factors. So what multiplies to get 6? Well, we could do 1 and 6, and we could do 2 and 3. To multiply and get 3, we only have 1 and 3. Now, the greatest factor of 3 is itself, and I notice that 6 also has a factor of 3. So in this case, the GCF of 3 and 6 would be 3. So when we're looking for the greatest common factor of a polynomial, we might be able to pull out a variable raised to a power also, which we'll see in an example in just a minute. So once we have pulled out the greatest common factor, if there is one, and if there isn't one, then we're going to move on to how many terms are in the polynomial. So if we consider that polynomial that we had above, 2x squared plus x minus 6, I see that there are 3 things being added and subtracted. So that tells me that this is a 3-term polynomial. So after we've classified how many terms are in our polynomial, we're then going to follow these arrows depending on how many factor terms we have. So if we have a 1-term polynomial, we're done. It can't be factored into a lower degree polynomial. If we have 2 terms, then we're going to look for these 3 different things. Is it a difference of squares, a sum of 2 cubes, or a difference of 2 cubes? If it's a 3-term polynomial like the one we have here, we have 3 different possibilities to run through. Is it a square of a sum, a square of a difference, or if none of those, then we can try some other strategies to help us list all possible combinations of factors. And if it's a 4th-term polynomial, then we're going to factor by grouping. And if we scroll down a little bit, we can see what some of those different formulas are. So if it was a binomial that we are trying to factor, and it was a difference of 2 cubes, two squares, then we're going to use this formula here. So the first thing is we need to recognize that it's two things being subtracted. And then the second thing is that each of our terms can be expressed as something squared. And then we use the formula with our a's and b's as shown. If it's a sum of two cubes, then we need to recognize that it is two terms being added and that each of those terms can be expressed as something cubed. And then again, we use this formula on the right-hand side. If it's a difference of two cubes, then one thing, it needs to be subtraction of the two terms. And the second thing is that each term can be written as something cubed. And then we use this formula corresponding to that. Now, if there were three terms, then we had two possible formulas that we could use. If it was a square of sums, which we have here on the left, then we would use this formula here. And if it is a difference, a square of a difference, then in that case, we will use this formula here. These are very special cases. And if you forget these, then you can always derive them with using these alternate strategies by listing out all possible combinations, which we'll explore in a different video. And then the last one was the four or more terms, and you're going to try factoring by grouping. Now, no matter what process you use, whether it was a binomial, a trinomial, or a polynomial with four terms, you're going to repeat the process for every factor you produce. And the reason is because we want to make sure that those factors are prime factors. And I will point out that one case in which you may see that we'll need to repeat this process is especially if you use the sum of two cubes or the difference of two cubes. But that's not to say that it won't arise in other situations as well. And again, we'll see this in some examples. And then also, to check that you factored a polynomial correctly, one thing we can do is multiply those factors that we came up with using the distribution property. And then if we get our original polynomial, then we know that we have done our factorization correctly. So let's go ahead and look at some examples. So the first example we're going to do is factoring out the greatest common factor. So if we were given a polynomial, and in this case we have 18x cubed plus 27x squared, we would first check, first step for any method that we're looking at is, does it have a greatest common factor? Well, let's first look at the coefficients. We have 18 and 27. So I'm going to write all possible factors for these two numbers. So first off, to multiply to get 18, I could have 1 and 18. We could have 2 and 9. And we could have 3 and 6. To multiply and get 27, we could have 1 and 27. And we could have 3 and 9. So I noticed that the highest number that these two have in common is 9. So that is the first thing that we can pull out. Let me rewrite this over here. So we can pull out a 9. But there's also something else that we can pull out. And if we look at the x values that are attached, so we have an x cubed and an x squared. Well, the highest exponent of x we can take out is x squared because they both have that in common. So now we're kind of doing a reverse distribution property. So 9x squared times what gets me 18x cubed? Well, that would be 2 times x. And then 9x squared times what gets me a 27x squared, and that would be a positive 3. So again, if you are unsure as to if you factored this correctly, let's multiply this back out and see if we get the original. So 9x squared times the quantity 2x plus 3. If I multiply 9x squared times 2x, we get 18x cubed. And then 9x squared times 3, we get a positive 27x squared. So we got our original polynomial back, so this is the correct factorization. And you'll notice that the two factors that we have cannot be broken down into any smaller degree. All right, the next example we're going to look at is factoring by grouping. So remember that this is when we have 4 or more terms in our polynomial. And to do so, to factor by grouping, we're going to group the terms in pairs. So here we have the polynomial 6x cubed plus 3x squared minus 12x minus 6. So the very first thing we're going to do is we're going to put parentheses around pairs of terms. So the first pair of terms that we have is the 6x cubed plus 3x squared. And the second pair of terms that we have is negative 12x minus 6. So right now we just grouped the factors. We didn't do anything else but add parentheses. The next thing that we're going to do is we're going to factor out any greatest common factor for each of the sets of the parentheses. So here I notice that 6 and 3 have the greatest common factor 3. And x cubed and x squared, we can pull out an x squared. So when we do 3x squared times what gets us 6x cubed? Well, that'll be a 2x. And then 3x squared times what gets us a 3x squared? Well, that's going to be a positive 1. Same thing for the other one. We have negative 12x minus 6. Well, negative 12 and negative 6, they both have a negative 6 as a factor. And negative 6 times what gets us negative 12x? Well, that's going to be a positive 2x. Remember, a negative times a positive is negative. And negative 6 times what gets us negative 6? That's going to be a positive 1. So now we've factored out the greatest common factor for our two pairs of terms. Now, you'll notice that in our parentheses, we have the same expression, 2x plus 1. This always has to be the case when you're factoring by grouping. If you do not get the same thing, then you cannot use this strategy for your polynomial. It will not work. So now to get our final set of factors, we have our 2x plus 1. And then we also take the coefficients, or sorry, not necessarily coefficients, but our greatest common factors of each of our sets of parentheses. So 3x squared minus 6. That makes up our other factor. So here is our factored form of our polynomial. Again, if you're unsure if we factored correctly, we can go ahead and distribute each of the terms in our sets of parentheses to see, do we get our original polynomial back? And then we have another example, which is a difference of two squares. So our polynomial is x squared minus 16. So notice that the polynomial above has no greatest common factor, and there are only two terms. So if we go back to that flow chart, there are a few things that we can look at. Is it a difference of squares? And it was subtraction, so that's a possibility. It can't be a sum of two cubes because we are subtracting. And the only other possibility is it's a difference of two cubes. So let's look at those terms again. So x squared, well, that is already a square. So we can rule out that it's a difference of two cubes. It's going to be a difference of two squares. So the first thing we're going to do is we're going to rewrite this as a term squared minus a term squared. And so here's what I mean by that. Well, we already have x is being squared. And then what is this? What squared gets us 16? And that's going to be 4 squared. So I've expressed these as squares. And now I'm going to apply that formula. And so what the formula said is that we're going to take a plus b. So in this case, our a is x and our b is 4. So we're going to have a plus b. And then our other factor is a, which is x, minus b, which is 4. And so here are our two factors that make up x squared minus 16. So here we've talked about only 3 strategies for factoring, and then also the process that we'll use when thinking about how to factor our polynomials. In the next video, I'm going to explore how we can factor trinomials with 3 other strategies and do a few other examples using our flowchart. I hope you find this video helpful and wish you luck as you're factoring your different polynomials.